Hi folks, it's February 21st, Sunday. I'm sitting down for a change instead of wandering around outside. That's because I need props this time, my famous tinfoil props for a discussion on gravity. This one and the next one that I want to make, hopefully both today. This one, though, is about bone density, of all things. To review, my notion of gravity is that it's not a force, it's not energy, it's our plane of existence is the best way I've been able to come up with a description for it. And I suppose a boundary layer is the other one that I like using as a definition. And my famous aluminum foil props are used to help with this explanation, hopefully. In this case, this is gravity, all right? Now, I do again have to remind folks that I believe it's a non-dimensional plane. There is no space per se, but this is what we're stuck with. So at the beginning of the Big Bang, we have energy that's injected into our plane of existence, and the amount of energy creates complexity. So this becomes, our universe essentially becomes extremely dense and extremely complex. And what that does is essentially just fold up gravity into infinitely complex space, as you were. That's what we're stuck with, because that's how we describe stuff. So the energy creates complexity in the plane of existence, which is gravity. And this goes down to the infinitely small scale. So what we have then is a situation where areas where there is high gravity will also see high energy. And you could look at it from the opposite side, and that might be easier in that where you find the most energy, you will find the most complex and the highest level of gravity. So the sun, our sun, has an enormous amount of energy contained within a relatively small space, and an enormous amount of gravity. Earth, smaller, less gravity, but a set amount. One of the aspects of this that I think is curious and maybe something to think about is if it was possible to identify a specific unit of area of gravity, some sort of measure for a standard amount of gravity, would we find that there is a very specific finite amount of energy that can be contained within that unit of gravity? I think that bears thinking about, and I kind of like the idea. Now, what does this have to do with bone density? Well, as I said, we have areas where there's a lot of gravity, a lot of energy. So the Earth itself has a very specific amount of gravity to it. And on the surface of our planet, it's measured as 1g for us. And our bodies have adapted to that and responded to the stress of 1g by building a bone structure, an infrastructure, to hold us all together that is specifically designed to withstand 1g of stress continuously. Now, a curious thing about that is we are constantly under stress 24 hours a day, all our lives, to 1g. But our bones don't continue to get stronger because of that stress over decades of effort. Nature is very conservative. So our bones are just strong enough to do the job, and no more. Why would that be? Well, it's a matter of conserving the amount of energy that you need to build that structure. Now, bones take an awful lot of energy to build, and the more energy you need, the more you have to go out and find food. And if you can limit the amount of food that you need, or define it in a specific range without having to be frantic about it all the time, then that's a good survival mechanism. The more efficient you are with your energy needs, the better. And our body just kind of automatically understands that and only builds things to what is required and no more. So, on the surface of Earth, in 1g, our bones become a certain strength. When we leave the surface, and we know this very well, we go into orbit and we go into much lower gravity. Not no gravity, just a lot less gravity. We know that bone density drops. And there's no reason to dispute the fact that part of the reason for that is we just don't need that structure anymore. We don't have that same 1g stress on our bones. And our body recognizes that and says, well, I don't need to expend that energy to hold on to this bone strength, this bone density that I no longer need, and start shedding bone density. I think that's perfectly logical. But I'm wondering if another aspect of this, and I think it would be subtle, I don't think it would be a primary cause, but I'm wondering if, you remember I referred to the, is there a question of, or is there a set amount of energy per unit of gravity? And in low gravity, there is a lot less energy in a given space. Are our bodies responding to that by shedding mass which is another way of saying shedding energy, because mass essentially is just a certain amount of energy. So are our bodies adjusting to lower gravity because that lower gravity can't hold all that energy? I think that's worth thinking about. I have no idea how you would go about defining that. First, I have no idea how you'd be able to kind of define a unit of gravity and then see how much energy is allowed in there, and then separating out how your bone loss and distinguishing bone loss due to lower density of gravity because of its inability to hold any more than a specific amount of energy. I don't know how you go about doing that, figuring that out. And I would think that you wouldn't necessarily have to do it with the human body. I would think that any structure that we've taken up into space will demonstrate, at least really, really subtly, a loss of mass due to this notion of lower gravity not being able to hold on to that dense of an energy field, if that works. So we'll move on to the next subject in the next video. Talk to you soon.